All right. So this is a lesson on correlation. So this is section 9.1. Let's dive right into it. Okay. So let me put this in slideshow mode. Actually, it's probably going to be easier if I don't put it in slideshow mode, but I will change that after. So let's run through section 9.1. Everything about correlation. And so, depending on where you took statistics one, you may have already been introduced to this topic. I don't typically get to it, so I always throw it in as the first topic in stats two. So, a correlation is a relationship between two variables. Um, this relationship doesn't mean a cause and effect. It doesn't mean that one variable caused the other variable to occur. So it's not always necessarily explanatory and response variables we're talking about. It could be looking at the relationship between that you watch and your GPA. It's very unlikely that if you watch a lot of television that directly affects your GPA, although I'm sure it has a role in if your GPA is tanking. But I'm sure that there might be a correlation or your height in the years of education, depending on how you're looking at that one. So the data can be represented by ordered pairs. So the X, which we know from algebra is called the independent variable, and in statistics it's called the explanatory variable, which I find to be a bit deceiving because it's not necessarily explaining. And Y in algebra was called the dependent variable, and in statistics, we call it the response variable. So, again, we are not saying there's a cause and effect relationship just because there might be a strong correlation. But we still plot these points in a scatter plot using a horizontal and a vertical axis. So in a scatter plot, the ordered pairs are graphed as you would graph any ordered pair in algebra. So you have your x-axis on the horizontal and your y on the vertical, and you would plot these points. And then we would take a look at what type of relationship they were displaying. So for example, here are some scatter plots. These top two we can see have a linear relationship. This bottom left has no relationship whatsoever. So if it looks like you took a spray can and went all over the wall, then you know that there's just no relationship. There's nothing correlating between the two variables. And then there's also relationships that require a nonlinear correlation. Here we can see more of a parabolic shape. We won't be diving into nonlinear correlations so much, but we will be taking a look at the linear relationships. Also, from your algebra class, you talked about y equals mx plus b, the linear line, and the relationship between the slope and the sign on the slope, whether it be positive or negative, and the way that the line was directed. So if we look at here, top left to bottom right, that's a negative slope. Therefore, we're saying it's a negative correlation. And from the bottom left to the top right is a positive slope, and that would indicate a positive correlation. Now, what the heck does it mean to be a negative correlation and a positive correlation? Well, negative correlation just means that as one variable increases, the other variable is decreasing. So you have opposite directions, very strong opposite directions. And for positive correlation, it means that both variables are moving in the same direction, whether it both be increasing or they're both decreasing, that's considered a positive correlation. So same direction, positive, opposite directions, negative correlation. Let's take a look at some of these examples and let's see if we can decide whether they are positive, negative, or there is no correlation. So what if we were taking a look at temperature during the summer and the electricity bills? Well, temperature during the summer is it rises. What do we do as the temperature rises? We might put on more fans or the air conditioner. So I think that it would logically make sense that as the temperature rises, our electric bill also goes up. We have a positive correlation. But somebody might argue that they don't have air conditioners or fans, and as the temperature rises, they open their windows. The days have more sun. They might not have their lights on as much. They're definitely not turning on their heat. So I could see someone arguing that as temperature rises, their electric bill goes down because they don't need to use their electricity as much, which would indicate a negative correlation. So a lot of these are dependent on how you view the variables or your interpretation of the situation. So there's not always just one answer. How about the temperature during the winter and heating costs? Now, this one I'd have to say is a very strong positive, oh, no, negative correlation because as the temperature tanks, you definitely are going to have some sort of heating cost that's going to rise. Okay, we are not going to sit in our homes with 0-degree weather and not have any source of heat. It's very unlikely. So, whether that heating cost is oil or propane, or wood to put on the fire, whatever it might be, the heating costs will go up. So that one I think is fairly straightforward as a negative correlation. Number of years of education and your height. Now, this one, there's actually two arguments for it. You could say no correlation because I might be 6 feet tall and only have a high school degree, or I might be 4'10" and have my doctorate degree. So you might say, oh, the number of years of education and your height absolutely have no correlation. And that's fair based on that explanation. But keep in mind that if you looked at it through a different perspective, such as K through 12 grades, then you get taller as you move along your educational path. So you would say that this is a positive correlation that as I, compared to myself, get older, I also get taller if I'm simply looking at K through 12. So if we're comparing to ourselves, I would say it's a strong positive correlation. If we were comparing amongst others, then there would be no correlation. Frequency of brushing and number of cavities. Okay, let's see. Although, again, brushing is not the only thing that prevents cavities, although it does have a strong effect on whether you have cavities or not if you brush your teeth. We're not saying that one is a cause and effect relationship, but I would say in general, the more you brush, it is very likely the less cavities you have. So we would say that this is a negative correlation. They are moving in opposite directions. Number of churches and number of bars in cities in your state. Now, some of you might instantly go, no correlation, because churches and bars are completely separate. They have nothing to do with each other. Okay. And that's fair, except if you think about it, think of businesses in general: restaurants, churches, bars, ice cream places, banks. Uh, when you see more of them, why do we see more in one place over another? It is because of a third factor, which is population. So if the numbers of churches increase, it's most likely due to the people have increased, and therefore bars will also increase because there's more people. So the number of churches and number of bars actually have a very strong positive correlation, and that's due to the population as the third factor. Height of a husband and height of a wife, although there may be preferences, I would have to say that this is no correlation, as I have seen very, very tall men with very, very short women and vice versa. So this slide is just a solution slide, but again, it's open to interpretation. So, constructing a scatter plot, an economist wants to determine whether there is a linear relationship between a country's gross domestic product, GDP, and carbon dioxide emissions. The data is shown on the table right here. And if we wanted to plot this into a scatter plot, we could easily do it in Excel, or in your calculators, or in any statistical software, really. But it's really easy to do in Excel if we wanted to plot this. Or we could plot it in our Guru, which is what we're going to use. But I have prepared a data set. It's not this one, but I'll show you how to plot a scatter plot in our Guru this week. We will also be looking at finding the correlation coefficient and the linear regression line. So I will actually be showing you all of that, which is, well, yeah, it's for both 9.1 and 9.2. But I want to show you all at once so that we have one Rguroo type showing. But here's the plot. And again, it's just using a horizontal axis for the first variable and a vertical axis for the second variable. Again, it's not cause and effect. It's just taking a look at the plotted dots and seeing if there's a relationship. So here I can see that there is a positive correlation because it is forming a positively sloped line. And the closer that the dots are together, the stronger the correlation, the more space that you see. You see how these are spread out a bit, and this is kind of a tight line right here, but this is kind of spread out, which would lower the correlation coefficient. We would say maybe this is moderately positively correlated. Okay. So a student conducts a study to determine whether there is a linear relationship between the number of hours that a student exercises each week and the student's grade point average, GPA. So here we have some data that's collected, a very small data set, and we have a lot of exercise hours and the GPA, low exercise hours and a higher GPA. Okay, but we have a ton of exercise hours here and a high GPA. So just looking at the chart, I'm guessing that there might not be much of a strong correlation, but it's very difficult to look at a table and determine correlation. You really want to plot. So now once I plot this, I can see, all right, if anything, it's creating a horizontal line, which has a slope of 0, which is not positive nor negative, which means that we have no correlation here. So this is the data set that I have posted for you in our class. So if you look in our Blackboard shell under course content, I've created an Excel file for you that copies this data so that we can easily import it into our Rguroo. So at this time, I am going to head over to our Rguroo, my PowerPoint, start sharing my our Rguroo account. One moment for me to find it. Hold on. Here we go. Found it. There we go. All right, I'm already signed in. So once you get signed in, this is what it looks like. And it says hi to me. This little video button here is a list of tutorials. So if you get stuck, you can always look up here for something that you might be looking for. This book is like a PDF, a clickable PDF that gives you some help on putting in formulas or using our Rguroo. Remember, everything that I require for this course, I will be doing out with you. So you won't necessarily need to learn on your own when it comes to this software. There's also help videos throughout every one of these formulas, which I'll show you as we get there. So the very first thing that we have to do is we are going to need to import our data set. So we're going to come here to data, and you're going to go to data import, and I'll try to go slow, but remember, you can always pause this video and walk yourself through it. And we're going to go to import data set. Now, you will have already had to have downloaded the Excel file that I've posted in Blackboard before doing this. I probably should have mentioned that. So make sure that thing is downloaded and you know where it's downloaded to, because you're going to click choose file, and then on your computer, you have saved that file. Did you save it under downloads because you didn't do anything with it? Did you save it in a special spot? I saved mine right in my class folder, and I would double click this. Now I'm not going to do it because I've already actually uploaded it, but you would click and hit open. It would be shown here, and you would hit upload. So I'm going to cancel out of that because I've already uploaded this. And you would be able to see it at the bottom of your list. Now, you guys won't have anything in here, so this will be the only thing that you see. But if I double click on it in the list, I can verify that it imported correctly. So this is what you want it to look like. You want the titles to be at the top, which is by default how our Guru imports tables, is that it assumes the first line is labels and that everything else is data. So as we go through this course, I will be showing you how to fix your Excel file if you have more than one label, or if you don't have any labels, how to tell our Guru that there are no labels in this data set. So this is what it looks like. Once it's in, we're good to go. So we're going to close out the data tab. We're going to go to the plots tab. So the first thing I want to do is I want to see this data as a scatter plot. So I'm going to go over here to create plot. I am going to come down to scatter plot. Okay. Now, here is that little camera button. If you're like, oh my gosh, I don't remember how to fill this screen out, I'm so confused. We just have to click this little tutorial button and it will very nicely, and they're all very short videos, so they're very easy to watch. It will walk you through the steps of how to fill out the screen. If you forget or you can't find, let's say you don't want to rewatch this whole lecture video, so that's a really great go-to spot for help. So the first thing we want to do is we want to select our data set, so our old faithful data set. I want to tell the software what is my X variable. So our X variable in this set was the duration of time between eruptions in minutes. And the response variable was the time between eruptions. I mean, really, this is not a cause and effect. So it doesn't actually matter which one's X and which one's Y. But for the purposes of keeping it consistent so everybody's looking at the same darn thing, the way the PowerPoint was labeled was duration was X and time between eruptions was Y. Now I want to see the line of best fit. That's something you guys are going to learn in 9.2, but we might as well include it so that I'm showing you everything for our Guru in here. I also want to show the correlation. So, and this is least squares equation, which we're going to talk about in the next video. And I'm just going to hit my little eyeball. Okay, so the scatter plot, and again, if I didn't want the line, which now that I'm looking at it, I'm not really digging the line because it's not the line of best fit here. So I'm going to go back to basics. I'm going to uncheck the line graph because it's not a time series data, so it doesn't make sense to have the line connecting these dots. I realized that was not the line I was looking for. I actually want the least squares line drawn. So I'm going to hit the eyeball. I hit the wrong one. Ah, that's better. Okay, so now this gives me a whole lot of information. So here is the correlation coefficient that we were just talking about, correlation. We haven't talked about the scale yet, though, so we'll talk about that in just a moment. But here's the correlation coefficient is positive, and the closer to 1, the stronger the correlation. The closer to 0, the closer we are to no correlation. Okay, so essentially the correlation coefficient ranges from -1, a perfect negative correlation, which means all the dots would be perfectly lined up on this pink line, or a +1, which would mean a perfect positive correlation, which would mean all the dots would have to literally fit perfectly on this pink line. So I'm looking, these dots are very close to this pink line. They form a pretty strong positive correlation. So I am not surprised that the correlation coefficient is very close to 1, 0.97. That is very close to 1. So very, very strong correlation here. In the next section, we'll be talking about regression lines. This is your equation of the regression line. You have your slope, 12.48, and 33.6 is the y-intercept. Okay, so this is one way to get all the information. This is probably the best way to get all the information. You can look at the graph. You can see whether it's positively or negatively or no correlation. You get your correlation coefficient and your linear regression line equation. But let's say that you weren't plotting it, you just wanted the regression information, or you wanted a statistical report showing that. So yes, this is a beautiful little graph. You can export it. You hit your Word document button here. You can export it and include it in one of your mini projects if this is what you're working on. But let's say we're just wanting the statistical report. Um, you know what? I'm going to show you the statistical report when we actually get to more complicated readings of the graph, or maybe I'll bring this in 9.2. So for 9.1, this is what we need. We need the scatter plot and we need this correlation coefficient. Okay, let's head back to the PowerPoint now. Let's put it in presentation mode. Okay. As we saw, we used Rguroo, but it can be done in other statistical softwares to plot the scatter plot. And as we saw, it can do so much more all at once. The correlation coefficient, as I was talking about, measures the strength and the direction of the linear relationship. So whether it's positive or negative or no correlation whatsoever. And again, the closer the dots are to the regression line, the more the strength increases in either positive or negative direction. R, lowercase r, represents the correlation coefficient value, and rho will represent the population correlation coefficient, which we don't need to discuss quite yet. Typically, we are working with R. Again, the range of the correlation coefficient goes from -1 to 1. It's the perfect negative. This is a perfect positive. And this is absolutely no correlation whatsoever. So if it looks like the line of best fit is a horizontal line, that indicates no correlation. Notice for a perfect +1, all the dots are lined up like soldiers. Not one is off the line. The moment that one jumps off the line, it drops down to 0.9999 correlation, which is close to perfect. Here's some examples with the correlations. The perfect one. 0.8 is still showing a very strong positive correlation, but we got a lot of space. 0.45, still showing a positive direction, but we have a heck of a lot more space between our points. And -1 is a perfect soldiers in a line, negative correlation. -0.9, notice a very strong picture of a negative line, but we have some space here. And 0.04 is very close to 0. We're looking at almost an S shape here. This might not even be linear. But because we can't see a negative trend or a positive trend in the spaces everywhere, is why we would say that this is very close to no correlation. It's very close to 0. So if we're using technology, again, I've showed you how to put this data set into Rguroo, create the scatter plot, and produce the correlation coefficient. So we've done that. Okay, the fact that the two variables are strongly correlated does not in itself apply a cause and effect relationship between the variables. It is not saying, since we showed a positive relationship between the time of duration of the eruptions of Old Faithful and the time between the eruptions. So what it's showing us is that the longer the eruption is, then the longer the duration time between the next one. But it doesn't mean that one causes the next. They just happen to have a strong correlation. They have a relationship. When there is a significant correlation between two variables, you should consider the following possibilities. Is there a cause and effect relationship? Okay, so just because it's not always a cause and effect relationship, there are some cases where it is. But remember that just because there is a cause and effect doesn't mean that it's isolated. It doesn't mean that that's the only causation variable. There might be others. Okay, so let's try to think some of these through. So an explanatory variable might be a pollen count, and the response variable is the percentage of people suffering from allergy symptoms. Yes, there might be a cause and relationship. Typically, people who are suffering from allergy, it is directly affected by the pollen in the air, the amount of pollen in the air. So this could be a cause and effect relationship. Same with the amount of food that you eat and the hunger level. Okay, so the more food we eat, the less hungry we are, negative correlation. The less food we eat, the more hungry we are, still a negative correlation, and this is a positive correlation with the pollen and people suffering from allergies. Okay. Is there a reverse cause and effect relationship between the variables? Is it possible that maybe the response is what's affecting the explanatory? Is it possible that the relationship between the variables can be caused by a third variable? Like we talked about churches and bars, the third variable was the population. Okay, the variables that have an effect on variables being studied are not included in the study, are called lurking variables or confounding variables. They're there, they affect our results, but we weren't testing those variables. They just happened to be a part of the study. So, an example for when the response can cause the explanatory being the hotel advertising dollars, and the response being the occupancy rate. Now, you might think that, oh, the more you advertise, the more people that are going to come to your hotel. So, strong positive where explanatory causes the response, but that's actually not accurate. If you think about a business, I'm not going to advertise for my hotel if I'm already doing really well. Why would I spend money on something that's already succeeding? So it's the other way around. If you have a low occupancy rate, you are going to spend more money in advertising dollars because you need people to come to your door. So this is actually a negative correlation where the response explains the explanatory. Okay, sometimes there's a common response based on a common variable that is not a part of the study structure. So, divorce among men and percent abusing alcohol. So, if you try to think of a cause and effect, does divorce cause men to abuse alcohol? I mean, I guess it's possible. Does abusing alcohol affect whether a man gets divorced or not? It's also possible, but those seem a bit extreme for it to be a very direct cause and effect relationship. And it's much more likely that the unhappy marriage is the common ground for both variables. Okay, so as you have an unhappy marriage, that might increase the divorce rate and also increase abusing alcohol. The happier a marriage, it's possible both of those will decrease. Just a possibility. We're not saying that this is hardcore fact here. Is it possible that the relationship between two variables may be just a coincidence? Okay, so take a look at this case study. A required whooping cough vaccine was blamed for seizures that caused brain damage. True story. This is a true case study. It led to the reduced production of this vaccine due to many lawsuits. Parents, when their children were getting seizures and causing brain damage, they all said, hey, we all had this vaccine. This vaccine must be the reason. We blame this vaccine. Lawsuits happened. All of a sudden, the vaccine had an issue with production and with people wanting to have their children vaccinated. A study was done because as statisticians, we are and scientists were required to find hardcore data to back up these accusations and these lawsuits. So they took 38,000 children and found no evidence of the accusations between the link between the vaccine and these seizures. So people confuse the association with cause and effect. So even though there was a strong correlation, every single child was required to get this vaccine, but not every single child got seizures. These children were going to get seizures and consequently brain damage, whether they took the vaccine or not. And many parents really have a misconception on whether vaccines cause autism, whether they cause certain health conditions. And although it's not 100% ruled out, it is very unlikely. It is more a coincidental causal relationship than it is a cause and effect relationship. So this discussion about a correlation relationships and the correlation coefficient. And I will call it for today for this section. See you in the next one.